Long before towering oaks, dense rainforests, or even the idea of a tree existed, Earth was already alive with green. But this was not the world that comes to mind today. There were no branches stretching into the sky, no leaves casting shadows, no roots digging deep into soil, just a quiet, almost alien landscape where the very concept of a forest had yet to be invented. And yet, something was growing, something that would change the planet forever. More than 450 million years ago, during a time known as the Ordovician period, life on land was almost non-existent. The continents were barren, rocky, and silent. Winds swept across empty terrain. Rain fell onto lifeless stone. There were no animals walking, no insects flying, and certainly no forests. But near the edges of water, in damp, shallow environments, the first pioneers began to emerge. These were not trees or even recognizable plants. They were simple organisms closely related to modern mosses and liverworts. Small, fragile, and low to the ground, they clung to moist surfaces, spreading slowly across rocks and soil. At first glance, they may have seemed insignificant, but their presence marked one of the most important turning points in Earth's history, because these early plants were doing something that had never been done on land before. They were transforming the atmosphere. Through photosynthesis, they absorbed carbon dioxide and released oxygen, slowly altering the composition of the air over millions of years. This process would help create an environment capable of supporting more complex life, but their influence went even deeper. As these primitive plants grew and died, they began to break down rock surfaces, contributing to the formation of the very first soils. This thin layer of organic material would become the foundation for all future terrestrial ecosystems. In a sense, they were building the world from scratch. Still, this early landscape was far from what could be called a forest. There were no vertical structures, no towering forms. Everything remained close to the ground, forming a kind of green carpet over the land. It would take tens of millions of years before something new appeared, a quiet but revolutionary innovation. Structure. Around 430 million years ago, during the Silurian period, a new type of plant began to evolve. These plants developed vascular systems, internal structures that allowed them to transport water and nutrients more efficiently. This may sound like a small change, but it unlocked an entirely new possibility: growth. For the first time, plants were no longer limited to hugging the ground. They could begin to rise. For the first time, plants were no longer limited to hugging the ground. They could begin to rise. One of the earliest known examples is Cooksonia, a small, leafless plant with thin branching stems that reached just a few centimeters high. It had no true roots, no leaves, and no complex tissues as seen in modern plants, but it had something incredibly important: a vascular system. It could stand, it could reach upward, and that changed everything. As evolution continued, plants became taller, more complex, and more diverse. New forms began to appear, experimenting with different ways to survive and reproduce on land. Some developed simple leaves, others formed more stable root systems. Over time, these adaptations allowed plants to spread farther inland, away from the constant moisture of water sources. The land was no longer empty. It was becoming alive. By the time the Devonian period began, around 419 million years ago, the transformation was undeniable. Plant life had expanded across continents, creating the first true terrestrial ecosystems. But still, there were no trees as we know them. Instead, the landscape was dominated by strange, unfamiliar forms. Among them were early vascular plants like Rhynia, which stood upright with simple branching stems. There were also larger, more complex plants such as Asteroxylon, which began to show early signs of leaf-like structures. But perhaps the most unusual of all were the giant fungi. Yes, fungi. Towering structures known as prototaxites rose from the ground, reaching heights of up to 8 meters. For decades, scientists debated their identity. Were they plants, algae, something else entirely? Today, most evidence suggests they were a type of fungus, making them some of the tallest organisms on land at the time. In a world without trees, these massive fungal columns would have dominated the landscape, casting shadows over smaller plant life below. It was a forest, but not of trees, a forest of experimentation, a world where evolution was still searching for the perfect design. Then, something extraordinary happened. Around 385 million years ago, during the late Devonian, the first true trees began to appear. These were not the trees seen today. They had no flowers, no fruits, and their structures were unlike anything familiar. One of the earliest known tree-like plants was Archaeopteris. At first glance, it might resemble a modern tree, with a tall trunk and branching canopy, but it was actually a transitional form, part fern, part tree. It reproduced using spores rather than seeds and had fern-like leaves, yet it possessed woody tissue similar to modern trees. This combination made it incredibly successful. Archaeopteris could grow over 20 meters tall, forming dense stands that stretched across ancient landscapes. For the first time in Earth's history, something resembling a forest had truly emerged. But this was not just a visual transformation, it was a planetary shift. These early trees dramatically altered the environment. environment. Their roots penetrated deep into the soil, stabilizing it and changing erosion patterns. Their canopies created shade, influencing temperature and moisture levels below, and through photosynthesis, they continued to reshape the atmosphere. Some scientists believe that the rise of these early forests contributed to a significant drop in atmospheric carbon dioxide, leading to global cooling. In other words, trees may have helped trigger climate change. Life on Earth was becoming more interconnected, more complex, and more dependent on these green structures. But evolution never stops, and neither does extinction. As the Devonian period came to an end, a series of environmental changes began to unfold. Shifts in climate, fluctuations in sea levels, and possible decreases in oxygen levels created unstable conditions. Many early plant species struggled to survive. The forests that had only recently emerged began to change. Some species disappeared entirely, replaced by new forms better adapted to the evolving environment. This pattern would repeat again and again throughout Earth's history: growth, dominance, and disappearance. Over the next hundreds of millions of years, plant life continued to evolve, giving rise to seed-bearing plants, flowering species, and the vast diversity seen today. But those earliest forests, the ones that existed before trees truly took over, are gone. Not just changed, gone. Their forms, their structures, their strange and unfamiliar designs exist only in fossils, buried deep within layers of ancient rock. And yet, their legacy remains. Every forest that exists today, every tree that stretches toward the sky, carries a piece of that distant past. Because without those first fragile plants clinging to damp rock and shaping the soil, without those early experiments in structure and growth, without a world that once had forests before trees, none of this would exist. The air would be different. The land would be barren. Life, as it is known today, might never have emerged. And so, in the quiet rustle of leaves, in the shadow of a towering tree, there is an echo, a memory of a time when the earth was just beginning to turn green, a time when forests had no trees, and everything was about to begin.